When you watch The Weatherman on your local TV news, that is a form of artificial reality. There's no real map behind me. It's just a plain blue screen. A computer creates that illusion. Well, the next step is virtual reality, which allows me to interact with that artificial environment behind me. And as you can see here, this is a virtual reality game called Continuum, and I can actually move inside that space and turn around and see it from all kinds of different angles. Now, if you think this stuff is just for fun and games, you are wrong. There are some important and serious applications using this new technology, as we'll find out today when we focus on virtual reality on this edition of the Computer Chronicles.
Been made possible in part by PC Connection and Mac Connection, mail order software and hardware peripherals for the PC and the Macintosh, and the Software Publishers Association, providers of educational materials to help manage software. Don't copy that floppy.
Welcome to the Computer Chronicles. I'm Stuart Chaffee, and with me this week is Jim Kramer, president of Virtual Technologies. Jim, when we read about virtual reality these days, it tends to be about arcade games. You pay a certain amount of money and you put these goggles on your head and you shoot down aliens in 3 dimensions and so on. You are developing a virtual reality application using your cyber glove, which you call the talking glove, that's far more important and far more serious. Tell us how it works.
Well, the talking glove uses the gesture recognition capabilities of the cyber glove. Here I'm fingerspelling as the American fingerspelling alphabet, and as I'm spelling, those letters are being spoken and being displayed for us also.
So could you actually do words besides just the letters?
Sure.
Hello, Stuart. How are you today?
That's fantastic. So even though I can't understand sign language, I know what you're telling me because you've translated it for me.
Right. The talking glove allows a non-speaking deaf or deaf-blind person to communicate with a hearing person.
Jim, what you're doing there, I guess, would be called gesture recognition. What other kinds of applications would there be for gesture recognition in a cyber glove?
Well, you can use the same gesture recognition routines to control a graphic interface.
And we'll see some of that later in the program. All right, indeed, we'll see several virtual reality applications today, including the virtual hand, the data glove, the cyber glove, and cyber CAD. Now, you know a product category is maturing when it gets its own trade show. Well, at the recent Software Development Conference in Santa Clara, California, there it was, the Virtual Reality Show.
It's not quite Comdex yet, but it was the computer industry's first virtual reality exhibit. AI Expert magazine hosted the show, which included 6 VR vendors and products that were still clearly in the development stage.
We're looking at the Model T Fords of virtual reality. Resolution is low, the headgear is uncomfortable, but what's exciting about this showcase is the promise of the technology.
Crystal River Technology was one of the exhibitors. While everyone else seems to be focusing on the visual aspects of virtual reality, their approach is to work on virtual audio.
Since the visual systems that we're working with today are not very good, it's very difficult to build a very precise stereo imagery system. But we can build a very precise audio imagery system. And we're closer to closing the loop all the way to perfection. That is, building systems that are almost mistakable for real life.
You may think you need expensive equipment to experiment with virtual reality, but one company here claims to have an inexpensive system that lets you turn CAD drawings into virtual reality environments.
We provide full virtual reality functionality, working on a standard IBM-compatible PC, all being done with no programming required by the end user. So a complete, easy to use, and I don't want to forget, affordable virtual reality system that people can actually load on a stock PC.
But what can you actually do with the stuff? At Straylight Corporation, they're already planning the virtual shopping mall.
Another application is marketing research, where people are planning out store shelf plans. And researchers will take hundreds of subjects through a store that's a virtual store and let them select packages and items on the shelves and try different arrangements to find out what the most attractive arrangement will be for a particular product.
For the Computer Chronicles, I'm Maria Gabriel.
Days of virtual reality, we tend to think of it in a game or adventure environment, but virtual reality is also an important design tool. Here to show us some examples are Chris Allis, cyberspace missionary with Autodesk, and also Linda Jacobson, who is a computer writer and editor and specialist in the area of virtual reality, and who put together this handy-dandy guide to virtual reality from the people who make AI Expert magazine. Linda, let me ask you, there's so much hype about virtual reality and so much confusion about it. What is the state of the art right now? What is virtual reality? Where's the technology at?
It's coming out of the labs and into our laps, almost. Almost, Stuart. The technology that's called virtual reality has been around in the 40s and was mostly found in huge research institutions, mostly government-related, military-related. Then moved into the giant educational institutions and is now moving down into the labs and offices of private businesses that are creating systems for people like doctors and architects and scientists to use to help them understand their data.
And so we have cyberspace missionaries like Chris at Autodesk. What's the philosophy at Autodesk? How are you using the concept of virtual reality?
Well, right now we're working on developing just the basic software tools that software applications developers will use to write these applications. Up until now, people have pretty much been writing their own software no matter where they are. But in order for an industry to get started and to be widespread, the people who don't have expertise in real-time simulation need to have tools that they can buy, pieces of code and so forth that they can put together, so they only need to work in their particular areas of expertise.
Now we have a fair amount of tools, hardware here. Why don't you go through this whole setup for us, Chris, and tell us what's here? Okay, well, first of all, we're running this software, these simulations on PCs, a 386 here, a 486 here. We have a variety of I/O devices. Remember, VR is not about just exotic I/O devices. You can run it with a mouse, regular old Microsoft mouse, up to the more exotic sorts of input devices. Yeah, this is Data Glove. This is one of the two items that the public seems to mostly associate with VR. The goggles. The other are the goggles, the head-mounted display. You have the computer tracks this as you wear it. You have two small TV sets inside that show you what the computer is displaying, and it really allows you to be in the middle of the computer graphics. It allows the graphics to surround you and gives you a real feeling of being there. All right, let's start out with what you have over there on the right. What's on that monitor, Chris? Okay, this is actually something that we started working on when we wanted to get away from the feeling of VR having to have goggles and gloves. So I'm controlling this display just with a mouse and eventually with a keyboard. But it's still, the display is still, I'm looking up, I'm looking down, and looking left and right and so forth. So it's still governed from the viewpoint of somebody who's wearing a head-mounted display. So you are kind of moving around in that environment, controlling it with a mouse. I have balls here that are suspended in space. Now they're attached. I can increase gravity, decrease gravity, and so forth. I can. Again, you're not pulling that. You're changing the physical parameters of that environment. I'm changing the physical. Yes. Yeah. And I can even let me move in here a little bit, get a little closer, and I can even maybe grab one of these and make it heavy. And then if I detach one end, you get the kind of interaction, and now I can add energy to the system. And you get the kinds of movement that you might expect. Or if I reach down here perhaps and grab one of these, let me see. Right. And I can move up. And so you can sort of play in that world. Right. This isn't, say, a complete application. This is merely a demo that one of the programmers worked out to test out physics, to test out. Well, you have another one that maybe people can relate to, which is a billiards simulation. So, yeah, let me bring that up. This is when you add a little more complicated interactions to the simulation.
Wait for it to come up here, and again, you've got...
Now you're controlling where you are with the mouse.
With the mouse, and this is actually another kind of view. This is deciding that what I'm really interested in is the cue ball, and so no matter where I look, I'm going to be rotating around the cue ball. And give that a little shot here.
And so here you've got to be simulating the real physics of this environment.
Ooh, almost in. If I just move this over here, check it out, maybe with an overhead.
All right, Chris, what's going on over here on the left-hand monitor?
Okay, well, actually what you're seeing here is the same simulation that we were seeing earlier on the other computer with different graphics hardware.
So the ball's hanging from the two arches.
Right. This looks different, but the same software and so forth. It's being controlled this time by the head-mounted display, so that as this moves, the picture moves.
Excuse me, Chris.
Yes.
You have a volunteer.
You'd like to try it.
Yeah,
Okay,
I would.
so Linda will go into the world of virtual reality.
I'm in it.
All right.
And we're seeing then on this computer monitor what she is seeing.
There it is.
And so she tilts her head left, right, up,
actually,
down,
I can
etc.
move her in a little closer here, and she actually can get much more of a feel of just how large this model is. And as I change, say...
Now what are you changing, Chris?
I'm changing gravity there so that the pull on these tetras is slightly smaller. And
so Linda,
actually,
your world is changing as he's adjusting this.
I'm getting lighter and lighter, Stuart.
So if you just sight in on one of those, whoa, here, just steady down, and let's grab one.
Okay. How about that one?
So you're going to make that object heavy.
Yeah, and it settles down a little more.
And so
you
Linda,
can see that actually more if we increase gravity here.
Whoops, so Linda has to bring her head down to keep up with you.
Right. And so that adds in then that additional spatial sense.
Okay, now can we add the glove element now? What does this do?
Okay, well actually, in order to add the glove, I'm going to move over to another demo. This is actually older software than what we're
so not the latest
working with. Not the latest stuff,
how the glove
but
works
it provides a good example of
okay.
just how glove interaction might happen. So put this on, one finger per, standard issue.
Okay.
This is good. That's good, good, good. Okay.
So now basically this glove is the input device and the goggles are the output device for Linda.
Right.
So she can determine now what she's going to look at by pointing?
By pointing where she wants to move within the model. So at this point, if you make a fist...
So you're going to calibrate the glove right now. So it knows what a fist is and what an open hand is.
Right, and it's
and now we can see her hand on the screen in this environment. And Linda, tell us, what are you doing now? What's your experience?
Well, I'm definitely in cyberspace, and you could see I'm moving my hand. You could see my hand in cyberspace also moving.
So now if you point someplace where you want to go...
Let's go there. Let's go there. Let's go there.
And you just
Whoa, I just flew right through a column
hand.
there. Okay, let's go in the other direction. Let's go up. Can I go up?
Yes.
So you're in charge of this world, Linda. Okay, we're going to have to get out of this world, guys. We're out of time.
Oh,
sorry.
Close encounter with a chair there. All right.
Chris, Linda, thank you very much.
Thank you.
All right, here's a classic problem. Your architect is designing a new home, and you're trying to decide whether to spend more money for some extra goodie. But what will it look like, you say? With a virtual reality product called Walkthrough, you can get an answer.
It's very hard to show clients what something's going to look like if you're trying to represent it on a piece of two-dimensional paper.
Architect Larry Mortimer has solved that problem by using a new virtual reality program called the Vertus Walkthrough. It lets the client actually see a proposed design.
The other thing that Vertus allows us to do is to change things very easily. Even while we're having a session with the client, we can change parts of the model. We can add windows very easily. We can add furniture to the model. We can do what-ifs until we're just tired of doing them.
While the virtual reality software can't replace the real thing, it does help the client to visualize the architect's plans.
You're spending an awful lot of money in a project like this, and if there's a way that you can see the space and feel the space before it's built, then I think it makes the client feel more secure about the money that's being spent.
Changing the design is easy. You simply point, click, or drag. In other words, you don't have to be a computer expert to use the software.
You have the ability to walk through a drawing almost in real time. When we show a model to a client, quite often the client will ask, well, can we look at this view, or can we look down there, or can we turn around and look at what we just walked through? And with Vertis, you can do that. You can tailor what you're seeing to what the client is asking you right on the spot with just moving the mouse and clicking in various directions.
Vertis Walkthrough is available for the Macintosh for under $300. For the Computer Chronicles, I'm Maria Gabriel.
Virtual reality is that it lets us communicate with a computer in 3 dimensions rather than just 2 dimensions. Here to show us how is Jim Kramer, president of Virtual Technologies. Jim, your glove is called the Cyber Glove, and you've just put it on. Tell us exactly what's going on in that glove and what we're seeing in the screen here.
Right. This is a 22-sensor Cyber Glove. It has sensors over each of the 3 main knuckles of the main 4 fingers. It also has abduction sensors between each of the fingers, in addition to a wrist pitch and yaw sensor and a thumb rotation sensor.
All right, so as we look at the screen, what's happening?
Well, this is a fairly simple hand model, although it does show the functionality of the Cyber Glove.
And it's following the movement of all the joints in your hand right now.
Right. So as I flex my fingers, the different colored fingers on the screen are also flexing. What I'd like to draw attention to is the accuracy that we can actually control the glove.
We show the fingers actually touching to the point of
each
touching.
of the fingertips. And again, the thumb can rotate fully across the palm and give you a lot of different articulations of the hand.
Now, Jim, what are the sensors in the glove that can do this so finely?
It's a resistive technology that it's linear, and it gives a very high resolution output. And that's a big advantage, because a different size hand, for example, wearing the same glove, it will produce the same outputs from the sensors. So it's unnecessary to calibrate when you change hands.
Yeah, exactly. Notice you didn't calibrate when we began, but if I want to, I mean, can you calibrate that glove to fine-tune it even more?
Yes, you can. We have a slider menu here where you can change just the offsets and gain of each sensor. As I said, they're linear, so just
you can adjust every one of those points.
The 2 parameters are for each of the sensors, and so if I needed to fine-tune it, I can just grab on one of these sliders here and change that.
So you really have fine control over that calibration there.
Right.
All right, now, Jim, over here on this monitor, we're looking at what's called a joint histogram. Now, what is that? That's connected to this glove, I take it, right?
Yes, it is.
And I'll put that on?
Put that on.
Okay.
Each one of those histogram bars represents the value of a sensor from the glove. What we have up at the top of the screen, 0 to 255 directly from the A to D converter. And
okay,
so as
I've got the glove on now, and it's showing the status of each of my joints. So I'm bending my index finger.
Right, and the joint names on the side are inner thumb, outer thumb, inner index, etc.
And I can sort of spread. That's what you call the abduction.
Right.
Okay, now what is the point in this particular histogram? Is this how you would really develop it and fine-tune it?
Well, these are the actual values that the computer is seeing, and from that we're generating this graphic hand model that we're displaying here on the screen. So the actual hand model that is drawn is dependent upon the graphics processing capability of the computer, although in any case, those are the values that the computer receives.
All right, Jim, I want to ask you next to show me what you can actually do now with the glove and how you can interact with the computer.
All right. We're going to be using a Silicon Graphics workstation for our graphics processing. We have a standard PC that's doing gesture recognition. We have a couple instrumentation units, one for each of the Cyber Gloves that we're wearing, and some instrumentation units for various electromagnetic position sensors.
Okay. Now, the glove you have on, I see you have a black switch and an LED. What's that for?
Well, that actually enables the gesture recognition capability of the glove.
Okay, so your glove is on. Now, show us what you can do. What do we see on the screen here?
Well, this is our virtual workspace where you could use a head-mounted display to actually be immersed in the graphics, but instead we're just displaying it here on the flat screen monitor. What I'm able to do, and rather than using a mouse, I'm able to just make a hand formation, for example, the fist here, and the screen will actually follow where I'm moving my hand. And doing different hand formations like this, we're able to change the modality of the system. For example, I'm able to move this little green cursor. I can move it in by making this hand formation. I'm able to move it just in the XY plane. Changing a different hand formation, I can move just in the Z dimension, or with a single finger, I'm able to move the green cursor and the cutting plane anywhere in 3 dimensions at the same time.
Okay, now I take it this is actually a design tool of some sort, so you can manipulate that object and build something?
Right. I can position the cursor inside the object, and I can just, by pinching my fingers together, which is a very natural movement, I'm able to actually grab onto the object. After we've positioned it, I'm able to grab, for example, a face
and you can change
of the
shape
object.
of it.
And,
it's the kind of thing you would do with a mouse, pull and drag, only in 3 dimensions.
Right. You're able to do tasks in 3 dimensions here, which is something you can't do it with a mouse, and you're kind of get a feel for graphic material by doing this. And again, I can change the view, and if I would like, let me just grab it with a 3-dimensional move, and now I'm actually moving that edge off into the 3rd dimension. You can see how I've really pushed that out, and that's something you can't do with a 2-dimensional mouse.
I see you have a toolbox icon there. What do you do with that?
Well, it allows us to pick from a subset of tools. For example, here is a pencil, and as we move the pencil around in space, we're able to generate a 3-dimensional space curve, which is something that would be very difficult to do with a 2D mouse.
We can actually see the shadow of that line in space.
Let me rotate the room. Right. And then you can see it from the side.
Okay, what are the other tools there?
Well, the other, for example, we have a saw, which will actually separate the object. We can take it over and just position it inside the object. And now I've just cut the part in 2.
Oh, and there's the plane through which you cut it.
For example, yes. And so let me just pull the front piece away. And
you now have 2 pieces there.
We have 2 separate pieces.
So you sawed it in half and you can pull it apart.
Right.
Yeah. All right, how do you actually start out making one of these figures with a primitive shape?
Right, we're able to open the primitives box and then actually grab one of the primitive shapes. For example, this is just a box. We also have cylinders and pyramids, and then these are just the same as the other object that we started with. You can start by just extending it, shrinking it, grabbing on a face or an edge.
All right, Jim, you're using the glove now for gesture recognition, basically. I mean, what's the next step? When can I actually go pick the piece up and get feedback on it?
Well, yeah, we're just using gesture recognition right now to interact with the objects, but I think the real advantage of gloves is going to come when we're able to incorporate the hand model that we saw earlier and actually put it inside of an environment like this, grab on an object, twirl it between your fingertips, be able to have 2 gloves, bend an object, test the compliance of the object.
Okay, thanks very much, Jim. That's our look at virtual reality. Stay tuned now for this week's computer news on Random Access.
In the Random Access file this week, this is a special summer edition with a focus on software. Here are last week's best-selling software titles for the PC according to PC Connection. Stacker 2.0 was number 1, followed by the MS-DOS upgrade, EMM 386 6.0, Approach and After Dark for Windows. Rounding out the top 10 are Windows 3.1, WordPerfect 5.1, Norton Utilities, and both Procom Plus for DOS and Windows. Next up, Paul Schindler in our summer software review.
You ever have this problem? 2 different kinds of Rolodex cards? Meshing them can be tricky. The same goes for PC databases. Now, if you have data in both Paradox and DBase files, there's help from a Windows database called Approach. This database allows you to manipulate files created by the 2 top PC databases, DBase and Paradox, as well as corporate data in an Oracle database. Use graphics to jazz up your forms. Approach makes it easy to switch from form design to form test and back. Here, form design isn't a separate program, it's just a click away behind the pencil. Click on the stack of papers, and you're back looking at your data. The walking fingers put you in search mode. Another set of buttons, just like those on a VCR, enables you to go to the start or the end. Anytime you double-click on a field in design mode, it brings up a menu that allows you to change any aspect of the appearance or content of that field. Approach is $400 from Approach Software in Redwood City, California. For the Computer Chronicles, I'm Paul Schindler.
That's it for this week's Computer Chronicles. I'm Janelle Stelson.
Computer Chronicles has been made possible in part by PC Connection at Mac Connection, mail-order software and hardware peripherals for the PC and the Macintosh, and the Software Publishers Association, providers of educational materials to help manage software. Don't copy that floppy.
Videocassette copies of this program are available. Computer Chronicles also publishes a companion newsletter containing details on products demonstrated, plus background information on program topics. To order a videocassette or a subscription to the newsletter, call 1-800-366-9484 or write Computer Chronicles. Please specify program subject for